This is Review Guide 2, everybody. This is, I don't know if it's easier or not than the first part, but possibly. All we're going to do here is we're going to work on some translations. Remember, translations, see if I can get my iPad to cooperate. Let's see here. This is what f of x equals x squared. So I'm going to just kind of give you a sketch of him so you can see what he looks like. He's just a parabola. He is quadratic. See if he'll just let me grab him. It will not. Well, that is our standard parabola. Translate up by 5 units means 2, 3, 4, 5. I want my new parabola to be up here. Really easy to move parabolas up. I'm going to give this parabola a new name. I'll call it g of x. And all I have to do is take the x squared, the black parabola, and then move him up by 5 units. I just add 5 to him. I would grab Desmos and graph him at that point if you had a chance to check him. But just add it outside the function. Now, if I wanted to move him left or right, I'm going to give it a new name. This would be a translation if I wanted him to go to the left. X squared plus, x plus 5. That would translate him 1, 2, 3, 4, 5. The reason I'm pointing that out is this is what we call adding a term outside of the function. The function was x squared. It was a squared function. Outside, I put a plus 5. Inside the squared function, if I add 5, it moves him left. If I were to subtract 5, it would move him right. Okay, so left and right you have to put inside the function. Up and down you put outside of the squared function. And so that's going to be important for number 2. Number 2, I've got g of x, but it's an absolute value function. So now if you remember absolute value functions, the parent function, they just make this nice V shape. Okay. This guy, because inside the absolute value function, I can see he's got x minus 3. That moves him to the right by 3. So the actual g of x function would be looking just like the one I just drew, but he'd be shifted to the right by 3. And so in this question, they're saying, hey, move that red function, x minus 3, or absolute value x minus 3, left. So to move him left, I have to add inside the function. So let's give him a new name. Let's use a different color here. H of x, this new function, would be the same as the old function, but I would add 5 inside. Now that can be simplified. That's x plus 2. That plus 2 in there means shift me left by 2 units from the parent function. Parent function is the purple one. And so the green function is our new one. And look how far he has shifted from that red one. G of x is here in red. 1, 2, 3, 4, 5. My new function, the green one, is shifted to the left by 5 units. Problem 3, we're stretching functions to stretch something. Pretty simple. This is again an x squared function, so it looks something like that. To make him grow faster vertically, that means I want him to look like this. I want him stretched vertically. In this case, by a factor of 5, we'll call that new function g of x. To stretch him, just put a coefficient of 5 in front of him. And then every time you get an answer out of the x squared, the parent, it gets multiplied by 5 and grows much faster. It stretches vertically. This graph right here, this is just a linear equation. X to the first, y to the first. There's a couple ways to graph it. I'll show you the most powerful way, I think the most powerful way, which is to put it into y equals mx plus b form. Okay, so that means we want to get the y alone on the left-hand side. So let's just start doing that. Subtract the 2x. And I get negative 3y equals, when you subtract that 2x from the right-hand side, you want to park it right behind the equal sign. And the reason you want to do that is so it starts to look like this mx. And so if your mx is right behind the equal sign, it's going to look like that. Now it's not truly m yet because we do not have the y alone. We have to divide by the -3 here. And divide everybody. So y equals -2 over -3 is positive. Negative divided by negative. Positive divided by negative. And see, now it's in slope-intercept form, so it's really quick and easy to graph. Y-intercept, -2. Mark 2 points down. Your slope is 2/3. That means rise 2, 1, 2, and run 3. 1, 2, 3. There's our next point. Always count from the y-intercept, your rise, your run, and then draw on your line. And we're done. Now, a second way to do this first graph, number 4 here, is to use x and y intercepts. And to do x and y intercepts, real simple. You just make two ordered pairs, and they look like this. The first ordered pair, you let x equal 0. And this, see, it makes math easy because 2 times 0 is 0. And so the equation just becomes -3y equals 6. Divide by -3. Y is -2. That is a y-intercept. That was this point right there. Then I do it again, but this time I let y equal 0. So -3 times 0 is 0. And the equation becomes 2x equals 6. Divided by 2, x is 3. That's this point right there. I graph those 2 points, and I can draw my line through them. So that's graphing with your y-intercept and your x-intercept. Sometimes much easier, especially when it's in this. 5 should be a piece of cake because that's already in slope-intercept form. Y-intercept is -1. Slope is 4. Now be careful. Slope of 4 is the same as 4 over 1. So you have to count up 4. 1, 2, 3, 4. And then over 1. So this way by 1. Positive slope, it better go up and to the right because that's what they always do. Well, number 6 is about x and y intercepts again, so we just had a preview for that. We'll just do this. We're going to let x equal 0, so -3y equals 12. Divide by -3. There's our y-intercept. Let's do the x-intercept. This time we'll let y equal 0. So -3 times 0 is 0. So 2x equals 12. Divide by 2. X is 6. There we go. X-intercept and y-intercept. Or I should say y-intercept and x-intercept. Solve this system by graphing. This is a little bit tougher. So to solve a system by graphing, we're obviously going to graph it. We talked about the fact that this, everybody, is not the best method to solve, especially if you're working by hand. I'm going to put these in slope-intercept form so I can graph them quickly. So here's the first one. I'm going to subtract the 7x. Remember, I'm going to park that right behind the equal sign. I'll divide by -1. Y equals 7x minus 3. So that's the first equation. Here's the second equation. We can work him right where he sits. Subtract the x. -y equals -x minus 3. Divide by -1. Y equals x plus 3. So that's my second equation. So let's go ahead and graph them and see what we can determine. Again, not the best method to solve by hand, but lots of times what they'll do on a multiple choice test is they will graph them for you, and you just have to determine where the solution is. So let's do the purple one here first. Y-intercept down 3, slope 7. So 1, 2, 3, 4, 5, 6, 7. I'm just counting up 7 units and over 1. So we'll draw him in the best we can. Right about like that. Let's hope the other one comes out nice. Next one, y-intercept is 3. 1, 2, 3. So y-intercept is 3. His slope is 1, so he goes up 1, over 1. Holy cow. He landed right on a point we already had marked. There is our solution. So we just have to read that. His x value is 1, 2, 3, 4. These two share the solution. 1, 4. Very checkable. If I plug in 1 to the first equation, 1 plus 3 is 4, so the y value comes out to 4. 1, 4. If I plug 1 into the second equation, 7 times 1 is 7, minus 3 is 4. 1, 4. So they both go through the same point, and that's exactly what we're looking for. All right, the last two I am not going to do just because this thing's running a little bit long, and I just put out, we had 3 different videos on how to solve systems of equations, so make sure you go back and look at those if you need help.